Well, if we start, just a quick announcement for tomorrow, Wednesday. There's two options still. I think you can still sign up for the Minnesota Private College Job Fair tomorrow. There's a coach bus that the Career Services has. I know they sent out an email yesterday saying there's still spots on it. So if you're interested, just skip all your classes tomorrow and go to that as an option. It's probably the largest job fair that's available. That's what the Career Services is saying. It's the largest job fair that we offer for students. And it is down in the Minneapolis, and so it has a lot of companies from the Twin Cities areas at it. So the other thing is tomorrow we'll be hosting some students from McGregor High School for a session here. We'll be just doing two quick sessions with them on serial robots. We'll break up in two groups. And so we'll do a session from 11 to 11:30 and 11:30 to 12. It'll be in the Securian lab here. So if you're interested, you just want to sign up and help, you can do that. We'll show you. I don't know if you've done the serial robots. If not, it's not that hard. It's just a nice block-driven thing, and we just need one or two students along with myself to coordinate the students that are coming tomorrow. So if you're interested in doing that, sign up on that sheet that's linked in there tomorrow. All right. I'm trying something a little bit different this week here to try it out. It was suggested in an earlier survey and some feedback from students. You still are going to work on this QQSP stuff, and you still can go to this prompt, and there's a set of prompts you can type in and have AI do, particularly if there's a certain AI you want. But what I've also done is use two of the AI systems out there, Gemini and ChatGPT, and run the prompts through them already, so that I have the prompts and the results there. So if you don't want to take the whole time of copying, pasting, and formatting, because I often find it a challenge with these things to, well, one reason I haven't been doing this is that I have trouble formatting the the results from these language models here. So trying to get this format to look good is sometimes a challenge to me compared to what it is. Let me just bring up ChatGPT, for example. So like here, this section, when you ask ChatGPT, usually it has some nice formatting here. It has the code and color in these boxes that I think makes it easier. The output is nicely labeled here and stuff, and they have some nice coding for that. So I think there is some benefit. And I have trouble duplicating this when I copy and paste it over here and stuff like that. So I think there is still some benefit to seeing it here directly. But I also think I don't know how much of a benefit that is. So again, what I've done is just run these prompts through these AI systems and put them in here for us. And then what I'm going to do today is do a little bit more of a lecture walking through. It's kind of nice to be able to go a lecture because we have a lot of code examples. So we can go to a code example and we can then actually try out that code and run that code. So my goal here is to try to explain some of these concepts with this stuff and have you walk through or try out some of the code for this. So if you go to the Unit 6, go to the the learning resources. So we're going to look at pointers and recursive types, sort of stuff, and some advanced concepts here that I relate to variables and types. I don't think show up other places necessarily. I'm gonna a lot of the textbooks don't actually spend that much time on pointers and stuff and reference types and things like that. But I think this is a very important idea, and I think you as student programmers don't see as much of it as you probably should here. So that's why I'm spending a whole week on this sort of stuff where it is not even a whole chapter in these textbooks. It's just a section of these textbooks here. So again, I have linked in here the different programming IDEs we can try out. And again, we'll try out some of those today here. And then here's the prompts, Gemini and ChatGPT. I think I'll go through the Gemini replies today kind of as the base of this lecture for this. So, so let's talk about pointers and what pointers and memory addresses are. So in C and C++, you can work with memory addresses, which we call pointers, directly there. You may remember, like, if you've done data structures here and you've got a linked list or something like that, you can create in Java, you can have a pointer to another object or something like that. You know, whenever you refer to another object, it's really kind of a pointer to that. But all this idea of memory and memory addresses are kind of abstracted away from you in things like Java and Python. So we're going to try to dive a little deeper into this. So like, again, a pointer is just a variable that holds a memory address. And again, memory addresses are just where things are in point and stuff. So here's an example of some of this in C. Now, let's see, do I have a C compiler? Let's do the C+. I think this is C++. Yeah, let's do the C++ compiler. Oops. Darn, I copied and pasted those links in there. And so when I do that, it breaks the links because it doesn't put them as opening up in a new window. Let me just go through and edit these real quick. So again, we're going to try to look at this C++ and C versions of it. And that's going to introduce two operators, the star and the ampersand, and we'll look at what those two operators do as in these particular language as far as manipulating pointers and stuff, and working with memory addresses for these things. Let me just finish up these last two here. So if I go to this, and I go to our code here, I'm just going to take that code and paste that into a C++ compiler here and run that and talk about that. So again, well, I guess you probably haven't seen C++ really at all. So just a quick note on it. It's, very similar like Java or C. The one thing that's different here is output. We use these pipes to do output. So we have something called C out for the console output. And then we kind of pipe things to that. And we have a chain of pipes that go to the output. So when you see that, that's all this is just print statements, basically. It's just a different way of doing print statements in this language. But again, here we're declaring a variable. X is 10. That's a normal variable. Now we're declaring a pointer, so an integer pointer. And again, that has this little star here. in the declaration of its name, meaning it's a pointer. It's going to store an address and not the location. And then we're going to store the address of X. And to get the address of, we use this ampersand. Ampersand next to a variable gives us the address of that pointer. So imagine, I'm going to use my cups. Let me stop sharing this real quick and switch here. Okay. So here's my memory location. This would be like X. Here we'll put it. This might be where X is. Here. So this is my variable X, and this is its memory location here. And again, I can store an integer in there. Here's the integer 14. Here it's 10. I can store that in X there. But now what we're doing is we're getting the memory location. And again, this is the memory location, address 411. That matches the address here, address 411. And we're going to put that in another variable. So this is our pointer variable here, and it's going to store that memory address. And then whenever we do things like we print off, here we're printing off pointer here. Well, here we print off, if we print off pointer, it prints off this address. It's going to print off the address 411. Actually, it's more complicated. Here we run it. It's hex 7FFE8015855C. That's the hex memory address for it. I just wrote 411 here as an example here. See if I could bring this up. There. Okay, so that's my memory address here for this. Now, if we want to print off what we want to follow that address and print off the actual integer that's stored at the other location, we have to print off star, asterisk, star pointer. So star pointer will say, go to this, go to pointer, find the address there, follow that address to this other location, this location 411, and then in that location, look and give me the address for that. So that's what this is doing, is that are we storing an address, or are we storing an actual value? So if again, when we're storing, if we want the address of a variable, we use the ampersand of a normal variable. If it's a pointer variable, it stores an address. So then if we want to get what's stored at that address, we use this star. So this ampersand and star are used throughout. Let me share again. Switch my video back, I guess. So. So again, the ampersand and the star are used for this address stuff. So again, the star operator is also used for dereferencing a pointer, which means accessing the value stored in that memory address it holds for this. So, and the ampersand gives us the address of, it's the address of operators for this. Once we have this, once we have memory and stuff, we can do things like pointer arithmetic, which we'll see in a little bit, and some dynamic memory allocation. You can just allocate a set of memory and grab the addresses and work with it at a lower level if you want. So now how does this work in Java here? When we have an object here, and we create a new object. Let's see if I can. I wanted to sign in so I get a little wider screen here. So if we have an object here, and then we set something equal, another object equal to that object, what does that do there? So that does not make a copy of the object. It actually now references that object again. So again, if we have some object, and again, I'll wait in a little bit and do the cup example in a little bit when we look at an example of this for this. Similarly, to things like in Python, if we have an array and we make another, we set something equal to that array, these refer to the same pointer addresses, the same thing. So this, my other list and my list are pointing to the same array in memory. So we'll look at it in a sec for some examples about that here. So, okay. Before we get there, let's just talk a little bit about boxing and unboxing here, and primitive types and wrapper types. So in Java, we have primitive types like int, long, float, bool, things like that. We also have wrapper types that are wrapped around them, and they all start with a capital. So integer, long with the capital L, float, double with the capital D. These all wrap around these other types. So you've covered these. You've seen these before, like in Java 1 and Java 2 sort of stuff, places like that. So let's just talk a little bit about the more details about when to use one or the other. So when to use one or the other, and stuff like that. So again, the primitive types are a little more direct memory, maybe a little faster if it's a very a computation intensive thing or memory intensive thing you want to use. Wrapper classes provide really useful methods, toString conversions, that sort of stuff, where you can always say, like, if you have a wrapper integer, you can say like wages dot to, or you can say the variable dot, and there'll be a bunch of methods attached to that you can do. Null values, wrapper classes can have null values, and sometimes that's important to show through a set that this isn't a number, or we haven't set this yet, but it also can get us in trouble. So we'll see that. But even more important, when you're working with generics often, and things like arrays and lists and stuff like that, array lists, you generally have to use the wrapper class. You can't use the primitive class for a lot of these things. So there are a number of places where you have to use a wrapper class for these things. And then boxing and unboxing is just the automatic conversion. So if you have a variable x, you set it to 10, an int x 10, you say integer object equals x. That'll automatically convert this and set it. So you can assign these back and forth. And same with unboxing. If you do it the other way, it'll unbox it. So you can, there's automatic boxing and unboxing in Java between these primitive types and the wrapper types, right? For this. So when you're programming now, what are you using? Are you using integers with a capital I or doubles with a capital D? What did you end up? Or using the lowercase still? What? Just int? Yeah, just int. So, yeah. Again, some issues, performance, the primitive types are a little faster. You can run into some null pointer exceptions, but sometimes it's useful to have a null there. But again, generics here. Now you have to watch, remember object checking, object equality with equals equals. So equal equals compares the object reference of the wrapper type, whether they point to the same memory here. You want to use dot equals here. So if you have two integers, A and B, and you want to check off if A is equal to B, this is not going to work generally. You want to do this. And this is similar to how you use with strings, right? You're used to using this with strings that you've got to say, name dot equals, other name or something like that. So. Questions on wrapper stuff? Okay, let's talk about pass by reference or pass by values here. So we're going to get in this idea of calling when we're using functions and passing parameters as functions to this. I'm actually gonna grab this. So again, there's C code and C++ code, and I'm leaving that both in here. I want to see one or the other because I think it's important to start seeing some of these pointer things and talking about low-level stuff. Often people talk about that, but I actually like C++ a little better. It has a little different syntax for this, and I think it's a little cleaner syntax. So I'm going to look at this C++ example here. Let me just copy that and put it into our C++ compiler. So again, kind of like with Java, I have a main class here. I'm just putting this inside the, oops, nope, there's already a main here. Never mind, I've got to get rid of this main. Okay, so I've got two functions, a modify value and modify with reference, and then I have my main here. I have an integer variable y equal to 10, and I'm calling modified value with the y. So that passes it up here. I do something with it. I rename it to x up here, and I double it here. Now, the question is, does this change the value of x at all for this? And I notice this doesn't actually print out anything. Let's see if I can print out y here. Yeah, how do I print out a new line with y, you ask? Sorry, my C++ programming is, oh yeah, that's n line. That's what I want to do. Okay, I'll just run that. Okay, so originally y is 10, and we pass it up to this method or this function. We change it. But again, this is passed by what we call pass by value. So we're making a copy of it and passing a copy of it. So pass by value, a copy of the value of the variable is passed to the function. So here, y, when we send it here, is a copy of y is made, and x is set to the copy of y here. And so if we change x here, we don't change the value of y. So although we printed off y is 10, after we call modified value, it's still 10 here. When we print it off here, it's still 10. Now, pass by reference is different here. Pass by reference, we send up the memory address of x here. So here we're passing up the memory address, the memory address of y, and x is going to be a pointer, and it's going to take that memory address. Now in C++, you don't have to do too much for that. In C, you do have to do a little bit more with that. You have to, when you pass the address up, you actually have to say, give me the address of x, and then you have to declare it as a pointer. So with C, you have to do a little bit more low-level stuff and refer to this this pointer kind of with the star operator. A lot of that is built into C++, where we can just say, I just want the address of x, and then I can just use x directly here and y directly here. And just by putting this in, it'll pass by reference and send the address up there for us. So if we do that and we modify x here, that modifies y down below, because again, x and y now are pointing to this is just the memory address, which is, even though we copied this memory address, it is still a memory address, and we are then saying, grab that memory, whatever is at that memory address, and multiply it by 2 and store that back into that memory address here. So pass by reference will let you change the original stuff. Now, the question always comes up then is, does Java pass by reference or pass by object here? For this. And so let's look at this sort of stuff. Let's open up a Java. So again, you're welcome to try this stuff out here. Go in here, grab the Java compiler or your favorite Java, just open up NetBeans or whatever you want. Go in here, we're down here to this third prompt, pass by value or pass by reference. And we're going to look at this Java one. It is kind of a little bit of a tweak to get this off into work here. See if that's how we want this. No, and I need this function inside the main, I guess. No. Oh, I just need to make it public. Oh, we don't actually, oh no, we don't actually have the my object declared here. Okay, I can't run this. I get confused because before class I was working with your activity for Thursday, and there I'm giving you fully working code for you to actually compile and run here, where this is just sample code for that. So I was confusing because I was also looking and I was seeing these comments and these weren't over. I thought I cleared up these comments and I was realizing, oh, that was on Thursday's activity. Okay, so let's just walk through this. So if we have an object here and we pass it to a method here, what is actually copied over here? And if we change some value, change something in that object, does it change the original object here? So it's kind of weird, but Java is always pass by value, even with objects. However, when you pass an object, you're passing a copy of the reference to the object. So whenever in Java you're sending an object to as a parameter to a function or a method, we make a copy of that reference there. So this means that we can modify that object, and those changes will be visible outside the method here. So if we do this, thing here, it will change the object down here for this. So let's kind of look at what that means. Let me go back to my cups here. So okay, if this is our object here, we created this new object, we stored some stuff in it there, and we have the address in our main program for that. So this is set up here. Now we are calling, we're making a new, or we're calling and passing out to our method. What that's really doing is we're going to make a copy of that object of the address of that reference. We're going to make a new copy. So we're storing this address here. We're going to store that here. We're going to store another copy of that same address. So both of these cups here are storing that same address back here for us. So now this is in our function. We're going to maybe change this integer. So we're going to rewrite this integer to a different value, or whatever this value is. We're going to change that to a different number maybe here and store it. And then we return back to our main program. Our main program, if it looks at that object, we'll see the updated version of that. It's no longer 47, it's 48, because both of these are pointing to the same object. So we're making a copy, but we're not copying the object. We are copying the address. So we are making a copy of the address and passing the copy of that address here. Okay, so if we change that, that's how that works. But now here's the weird thing. If we are in our function and we set this my object to a new object, what happens then? So what happens, what happens then is we're creating a new object here with a new address, and we're getting rid of this address. And now we are saying this new address is in our function, and it points to some new object, good old object 2022 or 23. And we can store and we can update the integer there. But that no longer points to the original 4011 address with the 48 in it here. So even though we're changing it, we're not changing the original. So again, if you make a new object and store it, this is pointing to the new object, but the main program is still pointing to the old object. Oops, you can't see that. Let me stop. Let me share again. So again, when we pass an object in here, we're passing a pointer to that object, like, we're making a copy of that address and sending that copy to this new location. So that then we have two things going to the same location here. But again, if we make here, we're making a whole new object. So we're creating a new object with a new address and storing that in here. That is pointing to a whole new object for this. So again, it is kind of useful to understand how these pointers and stuff work. Now, I think you already knew this. This is stuff that comes from Java too, but a lot of times developers forget how this works. And I think it's kind of useful to see this internal stuff and how it works. So Python, similar stuff. Here we're going to use an array because arrays work similar to our objects kind of in Python here. So just so you know, there are two types of objects in Python: immutable objects, things like numbers, strings, and tuples. So if you declare a variable and set it equal to an integer like 47, and then you set it to 48, what it does is it won't, integer variables are immutable. So we don't change what's in there. We just create a whole new integer variable for that. So anytime we make changes inside a function or something to a number or a string, we're making, it'll automatically make a copy of that and change it here. But mutable objects are like objects, user-defined objects, or lists or dictionaries, and those can change. So again, if we look at this Python stuff here, we create a list, we create an array or a list-like thing, and we now call this method, pass the list up there. We add an element to the list. It will be reflected back here. But similar to Java, if we try to make a new list and set my list to this new list, that's different. That creates a new object. And now my list will point to this new object. And we've lost the pointer to this previous object for this. JavaScript is very similar to these things for this. When we pass an object, we create an object, we pass it up, we create it, we can now modify it, and that modifies the original. But again, if we create a new object, it doesn't reflect back here. Well, that is somewhat familiar to you, right? Okay. I'm going to jump back at pointers a little bit and talk a little bit more about pointers and dereferencing pointers. Again, this is very specific to C and C++ here. So again, in C++, we have we can declare a pointer variable, and we can dereference a variable and get its address. So $x gives us the address of X. If we want to print that out, we print out that pointer. If we want to store a new value in there, we say a star pointer or star variable name is that. So now let's talk about pointer arithmetic. I mentioned this earlier. So if we have an array in C++, and this works in C also. So here's an array of 5 elements. The array variable is really just a pointer to the first element in that array. So we can get a pointer to and we set it to the array, that'll point to the first element in the array. So if we print that out, it's going to output the first element 1. And if we add 1 to the pointer, that will point out the second element. So we can just once we have this pointer, we can just add, we can do increments on this pointer and point out and print off each value. So when you loop through, like use a for loop, you use pointers generally for this. And we do this sort of stuff where you can have this special variable that's a pointer into this array, adding 1 to it or doing this ++ on a pointer will automatically, it'll know the size of these memory locations and shift this pointer to point to the next element by adding that amount to that memory address for you. When we get to arrays, we'll look a little bit more at how this works in languages, modern day languages. So a couple of just notes. We'll talk more about null pointers and problems with that. Dangling pointers is a pointer that points to memory that has been deallocated. Here again, you can allocate an array and then you can free up an array, but you still might have a pointer to that, and that can cause bad things because other programs or other parts of your program can use that same memory address for something. So, and again, in Java and Python, there's basically implicit dereferencing. When you declare an object and you do something with the object, it automatically dereferences it. It knows that that object is pointing to a thing and how to do it. So you don't have to do anything as far as memory addresses in Java, Python, or JavaScript. There's no pointer arithmetic. There's no garbage collection here. So again, in C and C++, we have explicit pointers. We can have direct memory allocation and access. We can work directly with pointers and addresses. In memory management manual, you have to call free or empty or whatever. I don't remember what it is in C to manage your memory. In Java, Python, most modern languages, There's no explicit pointers. Everything's implicit. There's no characters for dereferencing, and there's no pointer arithmetic allowed, and everything is done automatically as far as garbage collection is done. So, I'm going to skip over. We've mentioned mutable and immutable stuff. There's some more stuff about that here. I'm going to skip over that. If you want to learn more about that here, you can. The other thing I just want to share is this: the term shared reference or aliasing. In my mind, they're the same. I think that's what AI is trying to say. It says alias is a specific case of shared reference. And to me, they're two words for the same thing. Is when we have two variables that point to the same object here. So again, if we have one object here and we have two variables here that point to the same memory address. So from here we can change what this integer is, and from here we can do that. And sometimes you want to do that, but sometimes it is confusing there because some part of your program might be changing your variable and you might not know it there. So you've got to be careful when you're doing that you know that that is happening here. All right. So again, they give examples of this. Like if you have in Python, if you have a list, an array or a list, and you said list 2 is equal to list 1, they now refer to the same list here. We didn't make a copy of it. So if we add 4 to our list and we print it off, it should print this off. You can actually try this. Yeah, if you copy this into a Python compiler. So again, if we have list 1 and we're making it 1, 2, 3, and we say list 2 is equal to list 1, and then we use list 2 dot append 4, and we print off list 1, it is printing off 1, 2, 3, 4. It is this append up here to list 2 affected list 1 also here. Similarly, if we change list 1, the first element in it, to 10, and we print off list 2, we'll get that print off, right? So these two lists, list 1 and list 2 are aliases for the same lists or shared references to the same list, right? For this. So you have to watch that in Python. JavaScript, similarly, you can do the same thing, object 1, object 2. Again, Python's nice because lists are automatically our objects, so we don't have to create it. We're kind of built in that way. Here we have to create an object here, and we set object 2 to object 1, and again we change the error age. And again, I don't think you're going to be run this exact code because we don't have the object type defined with the name and the age set up. But again, if you modify object 2 and then you print out object 1, it should print out this this age in object 1, even though you modified object 2 for this stuff. So again, we can run in the same thing. We have to watch whenever we assign one object to another here. In C++, we've got to watch the same thing. We can handle this at a lower level with memory addresses here. I'm going to skip over that here. How about Java? And so again, same thing. We have an object here. We're going to set object 1, object 2 equal to object 1. Now they again share their alias. They share the same reference here. If we change, call a setter in object 2, it will, and we call the getter in object 1, it will get the new value here. If we set something in object 1 and we get it in object 2, again, we'll get the updated one. These both point to the same memory address here. So again, we're looking at this sort of arrangement where we have, again, some integer here, and we have two variables, object one and object two, that both point to this shared thing. If in one we change this, it'll be reflected in the other one. This is an aliased idea, right? So again, we've got to watch that. What do we want to do? We can do copying. We can do clone or copy. There's usually a method for that where you can say, rather than saying this, you can do object one dot copy or clone. There'll be methods in there. What we tend to run into problems with is if an object creates or has another object inside of it, there, like let's say we have an order for like an Amazon, and each inside there we have an order line for each item or an order item, each item you've ordered. So you've got an object that has another object. A normal copy will not copy the underlying objects, will just copy the base object. So again, when you're doing copying, you often have to do what's called a deep copy, where you're not just copying the object, but you're copying the underlying objects that it's made up of also. We're kind of, so again, sometimes you want to do this sort of copying with objects. There are some ways to code things to make your classes immutable. Java strings are an example of this. So string is an actual class, but again, if you make a copy, if you set one thing to another, strings are immutable, so it'll automatically make a copy of it for you here. But generally, you just have to be careful. This is one reason why we often want to do scope down. So we only want variables available where they are, because again, we don't want other functions to have access to them. But be aware, sometimes you'll get into trouble if you have a local variable but you maybe send it or put it, make a copy of it somewhere else. Your local variable might go away, and so then what happens to the reference to it that you have from somewhere else? So let me go back to video here. I really wanted to just talk a little bit about generics because I don't think we talk about too much in our formal setting. So let's just talk a little bit about them here. I think like in data structures, though, how much do you deal with? Who's had data structures? Data structures. So in there, do you deal with generics, these template types, when you do lists and stuff there? I don't know if you do or not. So let's talk a little bit about that. So again, what are we trying to solve with generics? This idea of having an object or passing in some object, generic object into a class or something like that. So again, here's an example of a generic. We have a class box, and where it holds a single object of type T here. And then we can work with the contents of that and do stuff with it. And then, but when we actually, in the main program, when we declare a box, we say this is going to be a box that holds an integer, or this is a box that holds a string. So this is the type of object that we're dealing with. So when we say box greater than less than T there, that T is a type of that object, right? So did you use that syntax when you were creating like linked lists or stuff like that? Have you seen that? We did, yeah. Yeah. So for that. So just so you know, this is pretty common in languages to be able to declare a generic type of object here. And again, so then once you have that type, when you declare a variable, you just use that type So rather than like say private string contents or private integer contents, we'll just put that type there for this. And then you can access that type in certain ways for this. So generic started off in C++. I'm going to skip over that and how they worked there because again, I don't think you'll be using much. We see them a lot again in Java, C Sharp, because again, in Java and C Sharp have basically the same thing as far as these go, since they're so closely related here. And again, we often work with a list, like an array list of that type or a linked list of that type. And again, we can create a generic list that can work with any sort of, so we have an array or a list of integers, of strings, or our own, a list of orders or a list of employees, and our own objects can be added to that. I'm going to skip down here a little bit more. Yeah, so again, most languages now have generics of some sort of types here. At least more of the strongly typed languages have these things built in. So how are these implemented? So there's slightly different ways these are implemented. And I'm not going to go into it's not that important, but I just want to mention that Java has uses what's called type erasure here. So we kind of declare it as a generic type called object and work with that. It performs type checking during compilation, finds any type errors. However, after compilation, generic type information is removed there. So we compile it as if that T was a specific type called a generic or a type thing called object kind of. We assign it a type. We run it through the compiler, make sure there's no errors, and then we unerase that type so that at runtime, we can substitute any type in there because we don't know what type is going to be there. So C++ uses a different process for that as far as how it works. We kind of create a generic function or method for this with what we call templates, and we run these templates through. I'm not going to go into this to tell you, I don't really understand how C++ works with generic types. I understand how Java does here. And again, C Sharp, even though it's so similar to Java, it underlying uses a different, more of a C or C++ version of how it implements these generics for that. So. Okay, the last thing I want to talk about, and again, the generics and null pointers are, well, null pointers are kind of related to pointers again, but it's kind of a special area. So again, when we run into pointers or we're using pointers, we can get into issues here. So it's possible to have null pointers in C and C++ quite directly for this. I'm going to grab this C++ code and copy it into our compiler here. I'm going to put it inside our main, right? Let's see, what is this is gonna, yeah, I don't think this is actually gonna compile, I think. Well, let's just try this. So let's do this. Sometimes with these things, it's hard to know what should be inside the main reference and what shouldn't be with this. Let me just try redoing this. Oh yeah, we're still not, we don't have the full code. Okay, so let's walk through this. No. So again, if we have a pointer that's set to null, we can actually check for that stuff. So again, a null pointer, again, in C and C++ is simply a pointer that's usually 0 there. So now in modern languages, pointers, there's a special null value for null pointers or to store something there. But in C and C++, again, pointers are just integers that store memory addresses. And so a null pointer is just 0. So again, you can also just say a pointer is null or 0 here. And again, we're declaring a pointer. Again, it doesn't have to be called PTR, but again, in these examples, it often is. And again, this little star means it's a pointer, it's address here. And then again, we can check if that pointer is null here. And again, we can do this check just like we do comparing one integer to another there. If it's not null, then we can use its value. We can dereference it here. If it is null and we try to dereference it, we'll get a null pointer exception error for this here. So we have to watch that. Let's talk about Java a little bit. So again, in Java, we generally run this with objects. The most common thing, again, is you declare a variable to an object, but you haven't instantiated that object yet, right? So you might just say my object equals object. You don't even have to say equals null. You can just say that, which implies this there, because you haven't instantiated that object yet. And then if you try to do this object.do something, call a method of that object or access a variable inside that object, you'll get a null pointer exception or null object exception error. So again, sometimes you want to surround this stuff with these checks. If object is not null, then you want to do something here. So again, this is where we're getting in. If the object is null and we're going to do something, this will throw our null pointer exception or null object exception error for this. Now, because of the problems with null pointers in these languages, some new languages, particularly Kotlin, although I've seen it somewhere else, are introducing null safety issues here. So let's just talk again, and we use this, we see this in the Android mobile apps class. So if you've had that class yet, we run into null safety issues when creating Android apps for this. If you have some variable here and you set that to null, you get an error. You can't assign a null to a non-nullable type, these values and stuff. And there's a special question mark operator that can be used to declare something as nullable. So if something can be null, if you, again, there are sometimes, usually you want to just avoid nulls and never use them, but every once in a while you might want to use them. So especially when you're working with old code. So if with old code, you could say this is going to be a nullable string. So this is a string type, and the question mark means it's nullable. So you would set some initial value, and then you can set it to null later on. This is often used when we declare a variable and we don't have something to set it to initially. So initially, it might be null here. Similar to integers, stuff like that. we can set, what this is saying is a nullable age is null. And again, what we often see more is this, where we're just declaring it and we're not setting it equal to something to start with, meaning it will be null to start with. So there's also a safe way to call things where you can have some name and you want to do dot length, but you think this might be null. You can say name question mark dot null, and that'll check if this name is null before it does this dot length here. So, and then if it is null, the whole expression will just evaluate to null for this here. So again, in Kotlin and a couple, I don't remember what other language I've seen. We've seen these null safety. Have you, other than mobile apps, have you seen null safety anywhere in any languages? I'm trying to remember where else I've seen it. I think it's going to be more common going forward with some of the more, as I think I wouldn't be surprised if we see languages adopting null safety rules similar to this. So so one of the things I ask as a prompt is that null pointers have caused significant software failures. What are some that are out there? And I asked AI. Let's bring up the other AI too, because let's look at ChatGPT's responses. So they're citing different, so I asked it to find out instances which were caused by null pointers and what caused them. Gemini picked out a couple. This is the well-known radiation treatment machine that had some issues and was giving people the wrong amount of radiation for this stuff. And there are a number of issues there. And they're saying some of them could potentially have been related to null pointers. I've not necessarily heard that this was the case with this. Well, not strictly a null pointer language in a language specific. The underlying issue is failure to properly evaluate pointer-like variables and handle edge cases. So yeah, for that. So I remember the Mother's Day outage from 1990 that caused this outage. New software update here. But again, this was caused by a switch statement, and without breaks in a switch statement, this is not a null pointer exception. So one of the things, and that's why I say this in the stuff, is that make sure you validate these things. AI is still not very good at really understanding this sort of stuff. So again, this AT&T network outage was not a null pointer issue here. And then it's tried to look at some other issues here. Now, there are, and I was looking for specific security features. There, buffer overflows are a typical way of breaching security. So like, again, if you can access memory through a pointer, you can then start writing that memory and keep writing over the code often in the heap. and change the code with the right stuff. So there are buffer or again, pointer issues, null pointer errors and stuff like that often will cause security vulnerabilities, but again, that we don't have a specific ones. Now, ChatGPT talks about the WhatsApp remote code execution vulnerability of 2019. I'm not familiar with this, but they are at least with linking it here. Right. So this looks like this was an actual issue with this, and it was a pointer error. I believe Wikipedia here. So again, I like ChatGPT's response. I think I used the newest reasoning model for this one because I think I tried the older one, the free version, and it did not do very well here. But the newer reasoning model did better with finding examples of this. So, okay, let's talk about our last step, garbage collection, and I'll just highlight this. In general, you don't have to worry about garbage collection. Every language you use has automatic garbage collection and all that stuff. Garbage collection really only an issue when you're doing memory, dynamic memory allocation, when you're using malloc or new in C or C++. So languages like Java, C Sharp, Python, all those things have garbage collection built into them. I was wondering if, yeah. So again, if we look at these things, garbage collection is automatic in Java, Python, and JavaScript. You can't do dynamic allocation, or you can't really get yourself in trouble with these stuff, where you can with C and C++. So. Okay, questions on this? I'm interested to hear if you find me talking about this more useful than you just doing the prompts and that sort of stuff. If we, on Tuesdays, we just want to spend an hour going over this sort of stuff, and you find this useful, I'll try to put out some sort of feedback this week or next. I think I'll do this week and next week. And next week we'll ask for some feedback so you can see 2 weeks worth if you like it or not. So again, you do still have to do the QQSP. You don't have to necessarily copy all the responses in here, but you have to come up with your own student prompts after going over this. What do you want to ask it, and what response do you get from it there? And we do still need a quote and a question for this that we'll go over on Thursday. So by Thursday, we want this stuff. Oh, and so let me make this do 2022. It really bothers me that it never updates the discussion times correctly. I don't know why. Okay. So by class on Friday, we'll want you to have the QQSP done, and we'll use that to do some discussion there. And then we'll do the learning activity. I have this pretty well set, but I'm still finishing it up. I'll have that done tomorrow. And again, that will involve a lot of what we've been looking at today, but actual code for you to run and try out and that. So we'll look at having you run these code examples in a lot of different things and paste the output and describe the issues with a lot of sample codes for this. There will be an assignment this week. I haven't got to it. I'm still not quite sure what I want to do with the assignment this week. I'll try to finish that up on Wednesday also. So tomorrow I'll finish up the learning activity, have that posted, and update the assignment for this week. Okay, so I'll let you go through, work on your QQSP here if you want, and get that ready for Thursday. Sound good? Okay, I'm going to stop sharing.